You step outside at 9 at night to take out the trash. The moon hangs over the rooftops, and something about it is wrong. It looks twice as wide as it did last month. Your phone lights up with a headline. The lunar orbit has changed. Astronomers confirmed it this morning. The moon is coming down. Tonight it sits 340,000 kilometers away instead of the usual 384,000. Nobody can explain the change, and nobody can stop it. Here is what the next 2 years look like. First, understand what keeps the moon up there at all. Nothing holds it up. It falls around Earth endlessly. It moves sideways at about 1 kilometer per second. That sideways speed makes it keep missing the ground. Isaac Newton explained this in 1687 with a cannonball on a mountain. Fire it fast enough, and it circles the planet instead of landing. So a falling moon means something is draining its speed. In our case, it loses a fraction of a percent every month. A slow leak. The full spiral takes about 2 years. For the first month, daily life barely changes. The moon grows a few percent a week, and photographers love it. Then the oceans respond. Tidal force scales with the cube of the distance. Bring the moon twice as close, and tides grow 8 times stronger. 6 months in, it orbits 190,000 kilometers away. High tide in New York now reaches about 12 meters. That floods the subway and lower Manhattan twice a day. Shanghai, Mumbai, Amsterdam, Lagos. Every coastal city evacuates inland. 1 billion people move in half a year. The moon now looks double its old size and shines 4 times brighter. Full moon nights turn bright enough to read a newspaper outside. Every solar eclipse becomes total, and each one lasts over 10 minutes. The water was only the first warning. Rock feels tides too. Right now the moon flexes Earth's crust about 30 centimeters daily. You never feel it because the motion spreads across hours. At a third of the old distance, that flexing reaches 8 meters. Faults that slept for centuries begin letting go. Jupiter's moon Io shows where this leads. Jupiter needs Io's interior through exactly this kind of tidal flexing. The result is over 400 active volcanoes on one small world. By month 10, Earth heads the same way. Volcanic chains wake along the Pacific Rim. Ash filters the sunlight, and average temperatures start slipping. Meanwhile, the sky itself begins keeping strange time. A lower orbit means a faster one. Kepler proved it in 1619. The old 27-day loop drops to a week, then to days. At 42,000 kilometers up, the moon circles Earth in exactly 24 hours. It freezes over one hemisphere, the way geostationary satellites do. Half the planet now sees it fixed overhead, enormous, unmoving. Below that altitude, something irreversible happens. The moon starts orbiting faster than Earth rotates. Tidal friction spent 4 billion years pushing the moon away. Now the same friction reverses and drags it down. From this point, the crash needs no outside help at all. You are probably asking why 8 billion people just watch this happen. They don't. The fight starts in month 3. First idea: push the moon back up with nuclear weapons. The arithmetic ends that idea quickly. The moon weighs 73 billion trillion kilograms. Every warhead on Earth, used perfectly, nudges it 1 centimeter per second. The orbit needs a correction hundreds of times larger every single month. Rockets do even worse. Bolt every heavy rocket ever built onto the far side. All of them together shift its speed by millionths of a meter per second. Plan 2, escape. Mars becomes the obvious candidate. Launch windows to Mars open once every 26 months. Inside the 2-year deadline, exactly one window opens. Fewer than 700 people have flown to space in all of history. Even a crash program with 1,000 ships saves maybe 100,000. And Mars offers no air, no soil, and minus 60 degrees. One committee even suggests relocating people to the moon. That idea parks them on the very object about to break apart. Only one vessel can carry 8 billion passengers. The planet itself. So the money goes underground, into shafts and tunnels. Yet the moon will never actually touch the ground. In 1848, French astronomer Edouard Roche worked out why. Close to a planet, tides stretch a moon along its length. Past a critical line, the stretching beats the moon's own gravity. For our moon, that line lies about 18,000 kilometers from Earth's center. Call it 12,000 kilometers above your head. Around month 22, the moon crosses it. Cracks spread across the face you have watched all your life. The familiar dark plains split into continent-sized pieces. Within weeks, the pieces smear into an arc, then into a complete ring. Earth now has a ring system thousands of times heavier than Saturn's. It spans the whole sky and casts shadows at midnight. For a few weeks, humanity photographs the strangest view in its history. A ring that heavy cannot hold together for long. The debris collides, grinds, and keeps losing orbital speed. Then it begins coming down. It arrives as a bombardment stretched across months. Boulders the size of stadiums hit at 8 kilometers per second. Each strike outdoes the largest nuclear bomb ever tested. Thousands fall every single day. The heated sky ignites forests before any rock even lands. Earth has survived this exact treatment once before. 4.5 billion years ago, a Mars-sized planet called Theia hit us. The collision melted the surface into a global magma ocean. Debris from that impact gathered in orbit and clumped together. That clump was the moon. Hartmann and Davis published the theory in 1975. So a planetary crash built the moon. Now a crash takes it apart again. Can anyone live through the bombardment? On the surface, no. Underground, the odds improve. 10 meters of rock blocks the heat pulse from above. Deep mines, metro tunnels, and bunkers get converted during the 2-year warning. Governments stock them with grain, diesel, and small nuclear reactors. Submarine crews already train for exactly this kind of sealed life. The deep ocean shelters everything else. Water absorbs heat slowly. Below 1 kilometer, conditions barely shift. Creatures at the bottom never learn that the sky changed. For humans, the underground wait stretches for decades. The ring thins year after year as it rains itself out. A few outer fragments stay in orbit for millennia. Children born down there inherit a different planet. Only the sun moves the tides now, at a third strength. Nights keep a pale band of ring light instead of moonlight. If this sounds like fantasy, look at Mars. Its moon Phobos is falling right now. It drops about 2 meters every century. In roughly 40 million years, it crosses its own Roche limit. Mars will get a ring, then a slow rain of debris. Saturn may have finished this process already. In 2022, MIT's Jack Wisdom traced Saturn's rings to a destroyed moon. His team named it Chrysalis. It broke apart about 160 million years ago. The most famous rings in astronomy came from one lost moon. Neptune's Triton waits on the same list. It orbits backward, so tides pull it inward every year. In about 3.6 billion years, Triton shreds into a ring too. Moons fall apart on schedule all over the solar system. Now check on your own moon. In July 1969, Apollo 11 left a panel of mirrors on the lunar surface. Observatories have bounced laser beams off it ever since. The round trip takes 2.5 seconds, accurate to millimeters. 5 decades of data agree on the verdict. The moon retreats from Earth by 3.8 centimeters every year, about the speed your fingernails grow. Earth's own tides push it outward and slow our rotation in exchange. Sediment records show days lasted 18 hours 1.4 billion years ago. So the real story runs opposite to everything you just watched. The moon is drifting away, far too slowly for anyone to notice. Step outside at 9 tonight and check. It hangs over the rooftops, exactly the size it should be. 384,000 kilometers away, and 3.8 centimeters farther than it was last year.